In this video, we're going to look at the composite function. So let's look at the definition first. Here's one definition of a composite function. So it's given two functions f and g. The composite function, denoted by f circle g, like a little open circle there, is defined by this. F circle g, or f composed of g, we can say it that way, or f composition g, is the same thing as f of g of x. So we're looking at a function of a function. And then it's important to know this: the domain of the composite function f circle g, or f composed of g, is a set of numbers x in the domain of g, such that g of x is in the domain of f. We'll look at this definition in more detail in another video. Right now we're just going to look at the basic idea of a composite function. So if you're familiar with this, you can go ahead and see if you can compute this out. So we have the two functions, f of x equal 2x, g of x is equal to 3x squared plus 1, and we want to evaluate. You can pause the video and see if you can do them, then I'll be back. So let's look at just regular evaluation of functions before we look at these particular ones. I got f of x equal to 2x, so if I give you, or I write out f of 3, that means I want the value of this function when x is 3. So put a 3 where the x is. 2 times 3 gives me 6. So that's just evaluating basic functions. I look for this function and say, well, let's find what is f of negative 9. Well, replace the x by negative 9, we get negative 18. But you can also evaluate an expression. This function had some expression. For example, I can say, well, what is f of 10x? Instead of a number, I have an expression. Same thing. We want to evaluate f of x equal to 2x at 10x. This would just be 2. Where the x is, we put the 10x. And this gives me 2 times 10x is 20x. And the same thing with g, this function. If I say, okay, what is g of 1? Place the x by 1. So it's 1 squared is 1, times 3 is 3, and 1 gives me 4. So now let's look at the composition. So the way you set this up, if I look at A here, I want f composed of g, evaluated at 4. So I can write this as f of g of, and just put in a 4 there. So then this is equal to, and where the g is, you put a 4. So it's 4 squared here. That's 16 times 3 is 48, and 1 is 49. So this then becomes f of 49. Now we got the f function. Now we're looking at this function here. We want f of 49. So that means we replace the x by 49. So we put a 49 where the x is here. That's 2 times 49. And that gives me 98. Okay, let's look at the next one. And we want g composed with f at 2. So we want to find the value of the composition function g of f of 2. So this becomes g of f of 2. And then we just work from the inside out. This is g, and then f of 2, we go to the f function, put a 2 where the x is. 2 times 2 is 4, so this is 4. Now we go to the g function. We want g of 4. Come over here and put a 4 where the x is. This will be 4 squared. 16 times 3, 48, and 1 gives me 49. So we're just evaluating composition functions, a function at a function. So now we have f composition f with itself. Same thing. We look at f of x, where x now here is 1, so we put a 1 there. And this becomes an f of, and then we just evaluate the f function at 1. So put a 1 over here where the x is. It becomes 2 times 1 or 2. And then, well, now we want f of 2. Same thing, go to the f function, put a 2 where the x is. 2 times 2 gives us 4. And go to the next one, the last one here, again, g composed of itself. G composed of g. G composition g. So this thing can be written as g evaluated at g of 0. So this is going to be g of, then we go to the g function. G of 0, put a 0 where the x is. You got 3, 0 squared plus 1. This is 0, so this is going to be 1. And then we go again to the g function. Now this is a 1 here. Evaluated at a 1 here. So put a 1 where the x is. 1 squared is 1. Times 3 is 3. And then 1 more is 4. And there you have it. So these are the basic ideas of evaluating a composition function. I will go into more detail in another video involving, say, the domain of the composition function. Thanks for watching. We'll see you next time.